we're going to look at sources of the magnetic field. And one source of the magnetic field is a permanent magnet. And we've seen that if I have a permanent magnet, I have magnetic field lines that go from the North Pole, they loop around and go to the South Pole. And the field lines are circles, because they actually continue through the magnet, but the field lines go from one pole to the other pole and then keep on going. And that's one difference between magnetic fields and electric fields, is that magnetic fields are always circles. And we can see that even more clearly if we look at other sources of magnetic fields. And I'll show you one. One source of magnetic fields is a current in a wire. If I take a compass and I put a wire across it like so, and I'm going to put a current through this wire just by touching the two terminals of this wire to a battery, watch what happens to the compass. And the compass moves. And so clearly, a current in a wire produces a magnetic field. And the magnetic field, as you'll see in the textbook, actually goes in circles around the wire. It goes in circles around the wire. So the magnetic field lines are circles, and they actually go around the wire. But we can look at other sources that are based on wires. If I took the wire and I looped it and made a coil, I'll make a magnetic field as well. And here, I've got a loop of wire, and I have two terminals. I can connect this to a battery, and if I do that, what happens is I get a current through the coils, it makes a magnetic field, and the compasses line themselves up. So when I pass a current through this wire, the coil makes a magnetic field that comes out one side, loops around, and comes back in the other. So it's similar in structure to the field from a bar magnet. There's circles that go through the loop. Comes out this way, loops around, and comes back in like so. And we can see that because of how the compasses are lined up. But I have a question for you. What will happen to the field if I take the battery and I put it in the other way? So I reverse the direction of the current in the coil. How will that change the magnetic field from the coil? We'll give you some choices. Well, I think you can guess what's going to happen. If I switch the direction, what happens is this. I touch the battery, I still get a magnetic field, but the compasses line up in the other direction. The magnetic field goes out this side and loops around and comes back here. So it's going this way inside the coil. Magnetic field lines go this way. If I switch the battery, so I had it originally, the current goes in a direction to make a magnetic field go in this direction. And so switching the direction of the current switches the direction of the magnetic field. And we have rules that will allow you to determine the direction of a magnetic field from a particular current source. You can make magnetic fields with permanent magnets. We've seen also that you can make magnetic fields by having current in wires. And we'll see in the chapter there are three sources of magnetic field from current-carrying wires that we'll consider: a straight wire, a coil, and also something known as a solenoid. It's a cylinder of wire, basically. But now we want to think about what is it that magnetic fields do. Magnetic fields are produced by currents, but they exert forces on currents, as we'll see in the next segment.